All right, guys, welcome to another live stream. Um, Today's live stream, I'll be talking about, I think, short video I recorded a while back. Basically, talking about, error handling in Rust, right? Using the this error crate as well as the anyhow crate, and I would then go ahead to, show um, a live coding session where I talk about these things and would step from there, gradually, um, step from there and would go through the process of, writing it manually as well as, you know, then refactoring it to write it in, um, you know, to write it in a, using the this error crate as well as the anyhow crate to reduce the boilerplate code. So this is basically part of a video I made in the past. Basically, talking about how we handle errors in how we handle errors in Rust basically, and this is something that can also be it's not it's not a Rust specific stuff. Some concepts here are not 100% Rust specific, but as I usually do in my videos, I try to appeal to the general Rust or the general audience, software engineering audience, so that anyone who sees this video would find you know some certain level of meaning, you know, from it. Anyways, guys, welcome to to today's live stream. Um, so let's basically dive into it. So initially, I think I started trying to adjust my mic. Here. Um, so the thing is, I made a short video in the past where I was talking about two methods of handling errors, right? Two approaches, and I used different analogies to to paint this scenario. One of them was a restaurant. I think one of the examples was a restaurant that had a very organized complaint system, right? And the second restaurant had like a suggestion box, and it was very interesting because a lot of people wanted me to go deeper, and actually shed more light on it. This live stream is basically fulfilling that purpose. The good thing about this live stream is you do not need to start setting up a Rust environment. You could just use the Rust playground. As I'm already sharing my screen here, I'm using a live Rust playground. You don't need any setup or any local environment. You just need to, if you're interested, go ahead and write out the code. So I'm going to show three things in this live stream. One of them is going to be how I basically handle errors manually. We'll do this the hard way, and the purpose for doing this is that it is very important to understand what happens under the hood before you start to use packages or crates. Because packages, if you're coming from a JavaScript background, an npm package is the equivalent of a crate in Rust. So for me, this is something I did manually in my own code base that runs in an actual production environment where I manually had to write all my errors for months. Right, the purpose of doing this was the purpose of doing this was because I wanted to understand the what was happening basically under the hood, right, without you know using the crates and automating everything from the get go. So we'll start, manually, and then we'll work our way from there. So first off, how do we even set up a manual? um, you know, how do we set up errors or error handling manually in Rust, right? Um, so I will just quickly go into the code editor. So the first thing to do is to set up a variant, right? So let's say we not a variant, sorry, an enum that has different variants. So let's say we're working on an application hypothetically. We want like basically there'll be validation errors, there will be not found errors, there'll be database errors and stuff like that, right? So how do we do this? I write an enum, so I call it enum, and I'll call it, let's say, app error. So we know that our enum would definitely have variants. So let's say we have, for the purpose of this live stream, we have three variants. So we'll call the first one validation, and has text string. Then the second one would call not found, also a string, and the last one would call database. So text string. All right. So basically, this is our it should be pub, and yeah. So that's basically it, right? So it basically takes three variants. Validation for bad inputs, not found for missing data, database for when something breaks, on our end. Very simple stuff, right? So now, we now need to, handle the display type, because we are doing this manually, so we have to handle the display type. So I'm going to be writing a very kind of like a complicated code, but before we do that, we have to derive um, we have to write some kind of derived debug on basically a macro on our on our so that's derive debug. Cannot spell today. Debug. All right. So now, in order for us to handle the display, right, we need to like we need to type we need to like handle for every variant, right? So for instance, for example, what I mean by that is every single variant would need to have an arm that it matches to, right? So every arm would write a formatting string. So this basically the three arms in our in our variant would have to handle that. So let me just quickly write out the code. So write it by saying implement, so fmt display. And before we do that, we have to have to import fmt. So say use std. So from the standard library, we want to get formatting fmt, right? So say fmt display, right? So want to implement the display trait for our our app error, right? That's basically it. So now, after doing that, we'll write a function. So we'll call this function fmt, and this function will take three things, right? To take a reference to itself, then to take a formatter, right? So now, and yeah, and it will take a formatter, then it will return, a result. So reference to itself, okay, and take mutable reference to formatter, okay, underscore, right. So now we want to return fmt results. So after doing that, in there we will now like handle the would handle the variants from our from our right? Would handle that. So how do we do this? Do this basically by using a match statement. So if you're coming from if you have a little bit of experience about how exhaustive handling happens in Rust, you would understand the concept of the match statement and how you use it to you know to match. So now to handle different variants in our exhaustively. So we say match self. So first I want to self here is basically pointing to our so match self. So say self. So handle for the first variant. So say validation. So no need to write this out. I'll just copy it over. Validation. And because it takes a string, so MSG, so call it message. It's an arrow function. And we just call the right macro. Mhm. So this right macro f we'll say no, validation error, and we'll just pass in a message here msg. So we'll go ahead and do the same thing for the other variants. So I'll just copy this over. No need of writing it manually. Copy this over. Close. Copy this over once again. So we'll change the second one to not found, and we'll change this to not found. So not found error. The third one will change to database, and we'll change this to database error. Exactly. So with this now we've handled for 12 the variants we have in our basically what we are doing here is implement this trait on app error right. So yeah, that's the the first step. So now you can see that we've for every single variant we had to write a matching statement for it. So imagine a situation whereby we have 15 or let's say 50 of these variants, right? So what does that tell you? That tells you that we now have to go ahead and for each of those variants we now have to write this particular. You can see the way I duplicated. I have to duplicate it 50 times, right? We'll come to that later on. So the next thing that we have to do now is to write an implementation on to implement the error state. Sorry, the error trait on on app error. So it's a very simple one line of code. So I'll go ahead and write it and explain what it does. But it's basically based on experience and everything. I think it's basically for it's just in my opinion. I'll say it's pure ceremony. It's just an empty implementation that tells us that this is an error type. It does not do anything visible, right? But you actually need it. So I will go ahead and I'll do that under here. So the same format, say implement std error, std error for app error. Right. So this is basically it. If space empty bracket. So that's all we need for the error implementation. Then yeah, so that's basically it. So now we also need like a a type. Let's say we need a from a new type from, right? So basically when let's say something like we have like an IO error from the database or something, right? We need to wrap that database error in a from implementation, right? Um, so I'm going to go ahead and write out that code, and I trust this will begin to make sense when we get to the point where we have to substitute this all these boilerplate codes and all for actual crates or packages depending on the background on your background you're coming if you're coming from like Node you'll be more used to npm packages is the same thing as crates, right? So I'll go ahead and write an implementation for for a from, like implement the from on the app error itself, right? So I would, let me just quickly go ahead and do that. Say implement from. So the from would take to take stdio error, right? So we're doing this implementation for app error. Okay. So now we'll then write a function and we'll call it from, right? So say fn from, and this function takes error. We'll say stdio error, and it returns self returns self. Then we'll just pass in our app error database, and we'll convert that error to string. So let's say app error database. Yep. And in there, we'll just say E, which is this guy. We'll say E to underscore string. So that's basically everything. So we needed five lines to basically handle the case when an IO error happens in our DB. So basically we are wrapping it as as a database error. Now, right, let's now try to use everything that we've done in a main function. So would basically in this case we'll just use a hypothetical example as we always do, for the purpose of keeping this live stream as as short as possible. I don't want it to get too long. So now we are going to write first of all our main function. Okay. So say fn main. So normally the main function doesn't return anything. So first we want to we'll use a, okay, I need another function before I go ahead. So what this function does is this function would basically return a result, and we know that results has one of the ways we handle errors in errors, which it has two variants. One is the okay and the error, right? So what we'll do is we'll create a function. I'll just call this function fn. Let's say I want to get list of farms, right? So this function will take a reference to an ID, first an ID, and to return a result. The first variant is a string. First variant is a string. Then the second one is going to be our app error. So pass our app error and close it, right? So now we'll just do something very simple, right? We'll say if let's say if id if id dot is underscore empty, we want to do some things, right? So if that's the case, we want to go ahead and say we just want to return an error. So we're handling the error. So say app error dot validation. I kind of miss the fact that if I do this in something like VS Code, I get autocomplete and all that. But then I don't want to go through the process of setting up um, you know a new environment and all that. So just decided to use the Rust playground. Well, that's fine, right? So let's say, um, so we'll say farm, give it a response. So say farm ID cannot be empty. So we use dot into here. So if you're not familiar with dot into, it's it's kind of like it's kind of like using dots to string, right? Um, but I think the difference with this is that it's on the stack. As it's cheaper, compared to, I'm not really sure, but I think it's cheaper than using to string, because then like a string is actually allocated on the heap. I might not be correct, but it's something I'm going to look up maybe after this stream or whatever. So now we handle for the case where we have an empty ID. Then you know we say error for if the ID is not found. We want to handle that case, right? So we use app error, because remember we have this here, right? So say app error not found. In case you're wondering where that is coming from, it's coming from here. It's one of the variants in our we say not found, and we'll just pass a, let's say, format macro, and we'd say farm farm so ID um was not found, and then we'll pass our ID here. So now that we have this function, we now have to handle it you know in our main function. So for the first case that we'll handle it when we have an ID, and we'll try to handle it when we don't have an ID. So let me reduce this a little bit, so I'll have more room here. All right. So use the match statement. So say match, say get farm. So we'll pass an empty string first, right? And declare a function. And here I would say, okay. So the reason why we can, reason why if you're in case you're wondering where the okay is coming from, or let me just go ahead and write out the complete code, and after that, I will address that. So we'll use an arrow function, and would say, just print line. So print line is equivalent to saying console.log in JavaScript, TypeScript, whatever. We say found. Okay. Farm. So that's for when we found the farm. So now we need to handle the second arm of that. So that is the error arm. So at that point, we'll say e to this, and we'll just copy this over, paste all this error, and I'll pass e here where we have farm. All right. So this is you can already see how verbose it is to manually handle errors this way. You had to write a whole lot of boilerplate code, a whole lot of code, just because we want to handle a situation whereby we pass an empty ID into the get farm method or function, or a situation whereby the ID was not found at all for that particular farm. So you can already see what we had to do. We had to write a manual. We had to write an enum with three different variants. Then we have to implement the display trait on the app error. Same, the error trait on the app error. Then we had to wrap the database error around a from implementation before we can do that. So you can see that this is almost 15 lines of code, and this is just for just three variants, right? Imagine a situation whereby we have 10 of these. Now think about how long this would be, right? And let's say for instance we have other places where other different scenarios where we want to wrap the want to wrap in a from implementation. So let's say for instance we're sending data to an OLTP or OLATP, I think, an analytic database, right? We're getting data from there, whatever. and we need to wrap whatever error that is coming from there. We also need another from implementation for that. Right. So you can already begin to see how crazy this whole thing will get over time if we keep you know adding more variants, and because we're handling it manually by ourselves. This is something I did while working on smart farm AI, because I really needed to understand what is happening you know under the hood or behind the scene. If I was starting smart farm AI today, I would really not do this. I would not recommend this, but it's important to you know understand it to this level. So now I'll go ahead and run this code. Let's see what happens. Okay, so now I have an error. Expected one of okay found FNT at line. Okay, so we have an error on line 11, and this is one thing that is amazing about Rust. It has very detailed error messages and all that, so I can immediately understand what is happening here. So I know I missed one of the columns, so I'll close this and go back to line 11 to here, and I'll run this again. Hopefully this time I find okay. Implement display for okay. Implement FNT. Hold on. App error. I think let me just, instead of doing that import, let me just go ahead and let me say std FNT. Let me see what happened. Two breaks. Implement std FNT display error. Could not compile in playground due to one previous error. Which is interesting. Okay. Um. Okay. So let me see. So compiling playground, implement std fmt display for app error. Or okay, there is a keyword. There is a keyword implement with similar name. Interest, IMPL. Okay, I think I spelled. Oh, I see. The spelling was wrong. I wonder how I did not see that on time. So let me run this again. Another error. Okay, expected one of 9 possible tokens. All right. So formatter fmt. See. I think explicitly. Okay. So underscore. Explicitly ignore the parameter name. No, I don't want to ignore it. Hmm. So this is one thing, right? Fighting the, you know, um, fighting the borrow check and Rust, right? It's one thing that you have to deal with, right? And that's one thing about these live streams. They don't really, I don't really write out these things ahead of time before I jump on this stream. I think it's something I should start doing, where I basically maybe test run these codes, and also I don't stop wasting my time as well as people's time. But then we walk we'll walk through this one after the other, and hopefully we should be able to resolve it. But if ultimately we don't get to the point where we can resolve it, I'll just go ahead and give other examples, and show you how we can replace all these boilerplate code I've written here with using the this error crate, and also talk a little bit on the anyhow crate itself. And so basically this error says okay, just like missing the of said. So I have to add. Let me use F. Um, then this statement is not surrounded by a body. You know, if you have questions, you can always add. I think I have a message in the chat. Uh, hey, thanks, Judy. Thanks, Bobby. Yeah. So just some funny messages in the chat. Anyways, so I think I've seen the error. The error. I basically missing text like here implementation that I missed to add L, and here I missed to add the what did you call it again? It said I ignored the parameter name. So yeah, I forgot to add the parameter name. Yeah, so let's run it again and see what happens. So I'll close this and run this again. Hopefully, okay. Match arm without braces. Okay, so line 14, match validation. Okay, please. Okay, guys, sorry. The stream ended. In case you suddenly saw a blank screen, I don't even know what happened. Like, I don't know. Anyways, let's see if we can start again. Please, if you can hear me, please leave a comment somewhere. One of the chats. Anyhow, but for some reason, I don't know what happened. It just stream just ended. Okay, so I'll continue the process of our debugging, which we were basically trying to figure out what was breaking. So the latest one is the match arm body without braces. Okay. Match arm body without braces. Okay. Okay, I've seen it. So this is the error. I'm not supposed to use semicolon. I'll use this. So what other possible errors would my tie have? Okay, okay, yeah. What the error is, um, expected app error found this. Okay. Um, so, okay, let's run this again and see. Hopefully, we are at the place where we have, you know, hopefully, place where we have lesser errors. Crap. Okay. Okay. So now, a situation where we are cutting the error down most at a time. So at this point, let me reduce my. At this point, we have 24. What is saying? Okay, it's supposed to return. Okay, expected app error found. Okay, implicitly return as no trade or expression app error. Okay, remove the semicolon. Oh, yeah, I'm supposed to remove the semicolon because we want to return from here, right? So take this out, and this is one thing to note, to watch out for in Rust. Wherever you have to return, you don't have to end. Put a semicolon. If you put a semicolon, automatically signals to us that that conversation is continuing. But once you remove that semicolon, it returns immediately. So yeah, let's see if that would fix our last error. Okay, so um, it was a long ride. Walking down through all the errors. First of all, we had like um, an implement. I think we had an error with FMT, and it wasn't really an FMT STD error. It was missing. I was missing the L in implementation, of which Rust was actually telling me that there's a similar keyword in Rust. So if I test that again and we run this, you would see it will tell you that compiling program failed, blah blah blah. But if you take a look at this part, it says IMP STD whatever, right? But it goes ahead to tell you that there's a keyword implement with similar name. So it's telling me to go ahead and add L there. So that's one thing that is amazing about Rust that I love so much. So I just added that back. So we walked our way through that all the way to our match arm, all the way down to removing the semicolon that we added here. And now when we run this code, you can see that we are now handling a case where a farm ID cannot be found, right? So I'll minimize this. So because we didn't pass any ID here, this particular get farm function expecting a string slice of an ID, right? But we added this validation check here to say if the ID is empty, we just want to say the farm cannot be found. Right? The farm ID cannot be empty. This is wrong. Not spell it well. Farm ID cannot be empty, right? So yeah, that's for that, right? But then let's handle the case where we go ahead and we actually pass a farm ID. So let's say we pass farm ID. So we'll call our farm ID 22, and we run this, right? What are we going to get? So you can see we get this arm where it says found farm 22, right? Hold on. Get farm. Okay. Yeah, so it's yeah, exactly. So it basically runs for the parts where we we did not find that that farm ID. So it says error not found. Farm ID farm 22 was not found. Right now, um, I see that uh, so my life is let's pray for one, 7, 8 code. Um, so now, um, how many just because I want to you know for the get function. I found, uh, how is code uh, for sure to manage understand where this comes in. But the- for that, we'll just so basically, you know, in- so basically, important now. I go now comment it and still need everything I want to pass. Here I'll say validation. Okay, guys, if in case you could not, see my screen for a while, I've been having a series of issues since the live stream ended. So I'll just go ahead and explain again. So basically, we are now trying to refactor over 30 lines of code using the this error crate, right? And what I've done here is I've implemented, that same enum that we had. I've added the, the error to the derive, that is the macro as a macro on top of the enum, right? And I'm just going ahead to implement the match arm. So I'm going to show how that works. So now I'll copy out this. So I'll put 0 here, copy out this, and I'll duplicate it for, not found, as well as, the database itself, right? So now I would then go ahead and copy not found from here, not found error, and I would paste it in here and 0, and I'll call this database error. I'll also add 0, right? Then I think I'll leave it at that, right? I'll leave it at that for now. I'll leave it at that. Then for our DB, because we have a from wrapper, a from implementation wrapper around our database, so we are going to, manually, pass it here. So we'll just call this, I'll say from so std dot io dot error, right? So that's basically everything. So you can now already see how a few lines of code, automatically replaces over 30 lines of, boilerplate code, right? So now let's go ahead and let me go ahead and, walk you guys through what each and every one of these does. So if you take a look at, the error, that is hash error, right? So this here, if you take a look at this, um, you know, it attributes to, my display format, like the display format implementation that we did right here. So it's, it attributes to this, right? So that's basically what this guy does, right? That attributes to that. So imagine one line of code per variant. So one line of code, so each of this with this and this now goes ahead to, replace the whole match block that we had here. It's replacing the whole match block that we had here, right? So the point is that the derive itself, it generates my display implementation and, my error, right? So this particular stuff now replaces that particular stuff. This particular stuff now replaces this error implementation as well as the entire match block itself, right? So this two has been eliminated. Then for the wrapper we did for the database error where we used the from implementation, that's where this particular guy comes in, right? The from itself. So for that one, it basically generates the entire from implementation for us in just one word, which ends up replacing about, let's say, 5 lines of code, because this is 1, 2, 3, 4, 5. I won't call it 6, right? So ends up replacing 6 lines of code just with, with this guy, right? So that's basically it, right? Now at this point, we can still go ahead and, run the same test that we did. So I will copy this main function as well. No need to copy it. I will just cut it out because that's the only thing that is unique between the two implementations. So I'll paste it here and I'll comment this out and comment this out. And you can already see how, minimal our code now is. Very short, very easy for someone to understand compared to, where we had to wrap our database error in an implementation, a from implementation, where we had to write this ceremonial error implementation on app error enum, where we had to handle, those three, error variants, using the match statements for each and every one of them. And you can already see how just this has replaced all of this, right? Now, um, I'll go ahead and I'll go ahead and run this code again and see. So we have our ID pass, so we should automatically get not found. So let me run this. Hopefully, we don't have any errors. Okay, I have validation error. Okay, uh, validation error. Mhm. Okay, what does it say? Could not expected one of string literal transparent FNT. Okay, I think there is an if there is a transparent I think there should be a transparent FMT or something like that. I'm not really sure, or I would have to check. Let me see. Mm, okay. Uh, oh, I see the error now. So this has to be wrapped in double quotes, which is something I missed. So I'll do same for not found. I'll do same for database. And hopefully when we run this again, everything should be fine. So I run this. Exactly. So now we have, same, um, you know, main function, same, method and everything. But at this point, you know, we've refactored this code to, use, this error crate, which, basically throws away all these, manual error handling and formatting and all that for us, right? So now so if I run this, and we still get farm cannot be found, and farm ID was not found to stuff like that. So basically, you can already see how we cut down the code from all the unnecessary boilerplate code we had at the top, which was almost 30 lines of code, to just this, right, using this error crate. Now, the one thing that is worth noting is that um, at the end of the day, right, this using this error, is the same thing as when we use um, when we use pattern matching, right? I can still decide to to do validation where my validation is a 400, or not found is a 404, or let's say the database is a 500, internal survival or something like that, right? In this refactor I did, is worthy to know that nothing has changed, except the amount of code that I had to write, right? I can still go ahead and do everything that I want to do the way I want to do them, right? So let me just go ahead and show an example of it. So let's say I want to write a function. So I'll call this function handle error, right? Now this function handle error takes in the error, which is the app error enum. It will not return anything. So we'll just, so I can go ahead and do like match. I can still do this and say error. And here I will just go ahead and say app error validation. I'll pass MSG. So my message arrow function, I'll call it print. Sometimes it's really tiring to write out these things. So I'll just say this is a 400 bad 400 requests I'm actually lazy at this point. Pass a message here. Then I will just copy this 3 times. 1, 2. So I'll change this to not found, not found. I'll say 404. So it can be 404 not found. And this is now going to be like a database, which is going to be an internal server error. So 500 internal server error. Right. So at the end of the day, right, even with writing it this way, we can still, match against it, right? Any way we want to, right? So it doesn't take away anything. It just cuts down the amount of ceremonial code that we have to, write. Now the third part is, so I would basically add comments here. Say refactor using this great. Then I'll comment it. Right. So that's it, right? So this is the manual error handling, where we, with 3 different variants, we implemented the display traits on the app error. Then we, wrote the pattern matching, which is the match statement each of those variants. Then we implemented this ceremonial error traits on the app error, and we wrapped the database error in a from trait to handle the database IO errors. And then we went ahead to refactor that particular code, using the this error crate, and you can see how it already cut down the lines of code that we had to write. So we refactored it, using this error crates, where we now, have these errors here that we passed on top of each of the variants, replacing our match and the error implementation that we had before. Sorry about that. Right. And yeah, that we had before, right? And and then went ahead to still show that we can still handle error, the way we want, using like a match statement for each of those variants. It didn't take away any of those functionality. So the last part is the part where we talk about anyhow. So in the last video I made, the short video I made, I talked about 2 types of crates, right? The this error crate, which is what we just looked at right now, and the anyhow crates, right? So I'll call this anyhow. So basically, the anyhow trades is the other restaurant that basically has a suggestion box, right? So every customer that comes into the restaurant just goes there, throw in their, they just go there, throw in their complaints, whatever, right? So um, would be writing out some codes to test this out. Um, basically just to see how the code works, right? I'm not really sure we'll be able to test this out in a live environment, because I can't really, the test I have, or the code I have, in the code I have, I don't think it's something that we can link to, an external file, because this is, a live, playground. So the anyhow crate, right? But before we go into that, I will just go ahead and, write out the code. I'll go ahead and write out the code. Then, as we always do, I'll come back and I'll explain it. So I'll call it anyhow. I can already see it here. Anyhow, and in there, I'll pass 2 things. So I need context and I need, results. I'll call it context. The next one is going to be results. So now give more space so I can have more space to breathe. So let's say we want to read a file, right? So we want to read a file or something, right? So use S. So you use std fs, so file system. So we'll write a function and we'll call it read. Let's just call it read config. So this function is going to return results that will take a U16. So now, in order for us to read, this file, so we know that we already have fs, the file system imported here. So we say fs, not sfg, fs, and we want to read to string, right? And we pass. Let's say the name of this file is our config.toml. I don't know if I'm not sure if this Rust playground has a config.toml file somewhere. I've never really checked. I've never really seen it, but I guess it should. I don't know, but that's just right. So now we'll go ahead and we'll use we'll now say fs dot read to string and we'll pass a context. The context here is basically the error that failed, right? We don't know if it's a 500, we don't know whether it's a 400, we just want to give context, right? So we'll say failed to read config file, right? So then we'll use our error propagation, so question mark return. Yeah, so we'll say let's config be equals to this, right? So equating it to something, not just putting it to a variable. So now I'll go ahead and write out some codes just quickly so I don't take a lot of time. So I'll say let's port, say this port is going to be U16 equals to config. So that's config here, this guy. So I want to say lines, the lines dot find. So this dot find will take a closure. So I'll call this line 1. Yeah. And let me not say 1, say L. As so I'll say L dot starts with port. Then I'll add a context. Basically, the concept is just like saying, the error message in case that line is not found. I'll say no port line was found in the config. All right, so now this is beginning to overflow, so I have to cut this. So I'll cut this. Do this. Also do the same thing for find, so it's easier to read and understand. Okay, so we want to do that. Then we want to, in case if there's an error, we just want to break it off at this point and return everything, right? But if there is no error, we want to go ahead and split. So we'll split it using the equal sign, equality sign. Then last, once again, we want to send the context. So say context. So this point we'll say bad port line, or we could, once again, we'll propagate, but we could say instead of bad, we can say malformed port line. Then we want to trim it with any sort of white space and After that, we want to pass it. Then once again, if there is any error, undo this, want to pass it. Then if there is any error, we want to, of course, context once again, right? So at this point you can say the port ain't a valid number. Right, so propagate again, and so after everything we want to then go ahead and just return port. So okay, right, so the okay is coming from our results type because one of the variants, right? So we'll just say port, passing port in there. Yep. So now we need a main function, so we'll say function main, and in that place we'll use our match statement. So say match, name of our function is read config, so we'll say read config. So in that place we now want to handle the because it returns the result enum, right? So it has the okay and the or. So okay is where it's successful, the error is where it's not successful. So the okay will give us port, so to unwrap the port for us, and with an arrow function we can now say print line. So we'll say starting on port, just so here I would say port and error. So we say print line print line. I don't know why I'm print line. Say just call it an error. Hash. Okay. Call it E. So the E is coming from here, right? So I have to wrap these two in a string so I don't break stuff. Note. So one thing to take note of, like I've mentioned, is these things are not something that I've tested ahead of time or something. So I don't really know if running this is going to break or not. Because I don't know if the config.toml would exist in this our live playground, right? But then I will just run it and show the error. So so let me run it. Hopefully there are no bugs and all. Okay, mismatched closing delimiter. Let me see online, what is that here? Okay. Interesting. Find else has with ports, starts with ports. So I'll run this again. I'll run this again, and mismatched closing delimiter unclosed. So that means I did not close this guy. Oh, crap. Interesting. So I'll run this again. Main is defined multiple times. Yeah, of course. We have main from our previous. So comment that out, and I'll run this again. And previous definition. Okay, I'll just go ahead and comment out everything we have done before. So we have only our anyhow tests. Okay. There's a method starts with, not start with. So it starts with. Okay, run. Interesting, right? So like I said, Um, you know, so this basically failed. So you're saying failed to read, failed to read config file, right? If we go down to, you can already see that, it's saying no such file in category or, directory, right? So this is basically um, the error that we are getting, right? So the point here is that I knew that we'll not be able to run that, but the point here is that you can see that we don't have any no custom errors, we don't have any enum, we don't have any display implementation. The question mark operator just basically propagated whatever went wrong, right? And the context added like a breadcrumb for us, right? So failed to read config file, all those kind of stuff, right? So ideally we just read it directly from here, right? You can already see the error here, failed to read the config file, right? So you just basically added that for us. Just basically the question mark operator just propagated whatever went wrong. you know the context itself was basically we adding breadcrumbs, right? So for instance, failed to read config file. If we had like a real config file with a bad port, it would have also returned, the bad port. So that it just continues in that chain. If the port was not bad, but the line was malformed, it will return that. If the line was not malformed, but the port number was not valid, it will also return that. So basically, it steps through the chain, right? Um, you know, so now it's important to note or to understand the difference between when and when not to use each and every one of these, right? So, for instance, if you're working on something like an API, like in my case, I would always favor, the use of this error. Like I mentioned earlier in the beginning of the stream, I always go with this error because, I wouldn't want to be manually writing boilerplate code just to, you know, deal with few variants in an enum, right? And I'll automatically go with the this error because at that point I want to I know I probably have like API handlers and I need to decide if the error message is a 400 or a 404 or a 500, right? But within the case of with the case of anyhow like we have here, we cannot really do that. um you know you know because anyhow error just gives us one generic type, right? I can't really match on it, so I can't pick the right status code and all that. you know if I have to like send 500 for everything, that would be completely wrong. I cannot be sending 500 for everything, right? So to end this stream, right, it's been a long one. There's a simple rule, right? For this error, when the caller needs to you use this error when the caller needs to know which error type, right? So they are going to they want to know the type that they are going to match to, or react to differently, or route to a different response. Use it in places like libraries, API servers, anything where different error gets different treatments, right? Use the this error, which is what we had seen here. So I'll just go ahead and uncomment everything so I can, yeah. So this is which is what we had seen here. So this is our this error implementation. So you use this basically when the caller needs to know which type of error that it's dealing with, right? When you use it when you want to when you want to match, react differently, or route to a different response, right? Let's say you're working on like a library or an API backend server, anything with where you have different errors and you want them to have like different treatments. Now, for our anyhow implementation, which is this, so I would minimize a little. So for our anyhow implement is basically this, right? Um, you know, you use it when every error sort of gets like same kind of response, right? So a situation whereby you just need to print the error, log it, and exit. Something like when you're building a CLI tool, or you're working on scripts, or like a prototype or something, right? That's when you use and anyhow. But then there are situations where you can also mix anyhow and this error in an API server and all that. There are situations like that. In my own case, like honestly, what I did like I mentioned in the starting of this stream, initially what I did was in my own code base was I handled every error manually, right? The reason I did this was because I really needed to understand what I was automating away using a crate like this error, right? I did not want a situation whereby, I just went ahead and I'm using a library or, a crate or a package or whatever, right? Without really understanding what was happening under the hood, right? Like in this case, right? So in my case, I did this, but this is not something I would recommend. If I'm starting today, I'm definitely going to, be using this error. And there are places in my code base where I've, switched, to this error and all that, right? And it's worthy to note that, though I've used Rust as an example here, um, you can still find this in other languages. Like for instance, in TypeScript, you can get custom error classes versus generic throws, like where you use the throw. The same thing too in Go. I think I read that somewhere. Um, when I was, basically preparing for the short video I initially made. I think Rust, not Rust, Go has like custom error types, versus the FMT error F. I think it's the error F wrapping, right? So the choice between typed errors and catch-all propagations, these things exist everywhere, right? At the end of the day, it's basically different tools, with different jobs. All right. So if you've come, from my short video that I made and wanted a deep dive, I hope this clicked for you. Drop a question in the chat. Let me know what you think. And I'm sorry that the stream ended a couple of times and all that. I don't know what happened. The streaming software I'm using, it just happens that way. Anyway, guys, thank you so much for joining me on this one. I know there are times we got tangled in the whole bug and trying to fix syntax issues, where I missed and implementation where I missed L, where I added semicolons, where I instead of removing the semicolon, I added it, and it failed to compile because it was expecting me to return something and it showed that I was returning an empty tuple. So it's interesting, right, to go through all those processes and from writing this long boilerplate code to refactoring it to something this short, and then showing the difference between using the this error creates versus using anyhow creates and the difference between the both of them. Anyhow, thank you guys so much for joining me on this one. I planned to keep this live stream to as low as 30 minutes, 25 to 30 minutes, but then it has taken over 1 hour 21 minutes. Thank you all for joining on this live stream, and I will see you guys in the